Let's move on to speed. Speed is one of the things that people start messing around with pretty early on because, let's face it, everybody wants their print to finish faster. Nobody wants to wait 6 hours for their model to finish. But, of course, as with everything else, speed has a big impact on print quality and print success rate. So just maxing out the numbers is not going to help you. Now, Cura has a few hierarchies to their print speed parameters. For example, initially there's an initial print speed, and this would essentially cover every category. However, going down from there, there are specific categories you can use to modify that initial print speed. So, infill, for example, you can set that to a higher rate because it's on the inside of the model. It doesn't necessarily have to look the cleanest, and you can have it cruising through there and save a little bit of print time without risking the model's external appearance. Just be careful. If you do infill too fast, you could end up with really weak infill if it ends up under extruding or just not extruding cleanly. So if it's a mechanical model, printing infill super fast may not be the best choice. You may want to stay with the same print speed that you use for your wall speed, for example, which is the next category, wall speed. And this gives you an opportunity to perhaps slow down the outer perimeter of your print to get a cleaner, nicer looking print with less artifacts. I would say that half of your average print speed is probably lower than it needs to be. You might find that something like 45 millimeters a second, and then maybe 50 millimeters a second is appropriate. You don't want the inner wall speed to be drastically faster than your outer wall speed, or vice versa. You don't want your outer wall speed to be drastically slower than your inner wall speed, but probably 5 to 15 millimeters a second difference is fine. Or you could just match them if you're really worried and you really want that outer shell to be pristine. On top and bottom speed, this is especially important for first layer, which we'll get to in a minute. But in terms of the speed that it does, the top and bottom visible portions of your print, a lot of this again just has to do with quality, so you can slow it down. In some cases, it may also have to do with bridging. How well is it going to bridge across infill or open spaces? I don't think it needs to be this slow. For most materials, it doesn't. But if you had it slowed down to outer wall speed or a little bit slower, depending on the part, and a lot of this is dependent on part geometry. For some prints, you can do top and bottom speed. Full bore is not going to affect it. Other more delicate or more technical prints, you may find you have to tune that down a little bit to get nice, smooth top and bottom print features. Travel speed is going to be a function of mainly your mechanical integrity of your printer. The benefits of going high on travel speed are obviously shorter print time. It also helps with stringing because the faster it can move that nozzle from one point of extrusion to the beginning of the next, the less time that nozzle has to ooze out any material whatsoever onto your print outer perimeters. So in those cases, higher print speed's better. Now the downside is that if your printer's mechanics or mechanical integrity can't handle it, then you're going to end up with well, you could potentially break your printer trying to drive it too fast if it were really in poor repair. But most of the time, you're just going to end up skipping steps where the printer's trying to move or is being told to move at one speed, but the resistance from the mechanics or the inertia is just too much for it, and you'll end up losing steps, and then your print's done immediately as soon as that happens. So travel speed is one of those things that once you find a good maximum for your printer, you'll probably keep it there most of the time. There's not too many reasons to slow travel speed down, even on highly detailed prints, because most of the time it shouldn't affect it because it's not extruding during that portion. It's just moving from one place to the next. Initial layer speed, this is really critical for people, especially if you're new to 3D printing and you're struggling to get those first layers to stick. I actually recommend going down to 10 millimeters a second and allowing the printer to really take its time laying down that first layer. Once you get more familiar with your printer and bed adhesion and some of the different tools and techniques, you'll find you can start to bring that speed up. But when you're just starting off and if you're having troubles with it, turn that initial layer all the way down to 10 millimeters a second, and that'll give you the best shot at getting a clean first layer without the print getting pulled off or partially dislodging or some of those other bad behaviors that can happen on the first layer. Skirt speed or brim speed, same deal. No reason to try to do this really fast. This is basically there to get that nozzle primed and get replace any bubbles or air bubbles in the nozzle that have occurred from the heat-up portion where some plastic might ooze out of the nozzle. And it's also a chance for you, if you're watching the print, to verify that your bed level is correct, that you don't have gaps between those layer lines that would indicate that your bed's too low or isn't level. So this value right here will actually print the first couple layers, or however many you specify, a little bit slower than the rest. And it's not a bad idea. Again, it's one of those things, if your printer's well set up, you don't need it. But if you're struggling with those first layers, having it do the second or even third layer a little bit slower can help make sure that that piece stays adhered to the build plate. Okay, moving on to travel. These are a couple interesting settings. Combing is the act of keeping the nozzle inside of the printed area instead of going in a straight line. The upside is that any oozing that it might do happens inside of the print, and so you have no path outside of the print that it could possibly ooze onto because it keeps it on the inside. The downside is that it has to move a further distance most of the time because it's not just taking a straight line, it's tracing a path inside of your part. The other downside is that if it's a thin-walled part and it tries to comb, it will actually be depositing, it'll be oozing because it doesn't retract. It'll be oozing plastic out onto a piece of the part that's actually too thin to really have infill. So if it's like an enclosure and the walls are maybe only a millimeter or two thick and it tries to comb, it'll make a mess all over your part. So there's some scenarios where combing is just not going to work, and you need to stick with standard retraction moves. But for larger prints that have enough surface area inside, combing can actually be a really good technique to get really clean exteriors. Avoid printed parts is pretty self-explanatory. If you've got multiple items on the print bed, and you also have combing enabled, when it combs or when it has to move from part to part, it won't pass over the tops of other parts, it'll move around them. And the idea there is that it'll prevent any small amounts of oozing from getting wiped off on other parts, or potentially hitting them and knocking them over if there's a little bit of curling and it's moving really fast. These settings often are used to compensate for issues in other settings if you don't have your temperatures right or you don't have a good cooling fan. So some of these settings aren't really necessary if you've got a good printer and it's set up well. But at the same time, if you're just dealing with what you have and you're trying to find ways to increase print success, giving these a try is certainly worth it. And then the final value here, avoid distance. This is simply by how much it will avoid printed parts if you have this option selected. So it'll make sure there's at least 1.5 millimeters between the nozzle and the next part. All right, cooling. This is pretty important. I'm going to use the Monoprice Select Mini as another example here, partially because probably a lot of the viewers watching this, at least right now, are actually from that forum. You've got to keep cooling fans enabled for this printer because the fan that actually just keeps the hot end cool is actually what's plugged into the cooling fan output. So if you disabled cooling fans, you'd literally be disabling your hot end cooling fan, and your hot end would jam up within probably 5 minutes of the print starting. So it needs to stay enabled. And if you're using the stock cooling setup, it needs to stay at 100% all the time. The regular and the maximum have to stay at 100% because if you even run that fan at a lower percentage than 100, you run the risk of the heat break not being cooled enough and of your printer jamming. So specifically for that printer and any other printer that uses the hot end cooling fan attached to the cooling fan output from the print control board, it's critical that you leave them at 100%. Now, for people using a printer that has a multi-fan setup, where you've got a fixed fan for the hot end, and then you've got a layer cooling fan that is used only for cooling the part and the layers. These settings are very useful, and depending on the material that you're printing with, will be at any number of different settings. Now, if you're printing something like PLA, which likes to curl or droop without cooling, for the most part, you can print at 100% fan speed. Maybe turn it off for the first layer while it's laying down that first layer, but for the most part, the entire print can be printed at 100%. And again, this depends again on your printer and how powerful the fans are. So this is something that you have to experiment with different kinds of parts, whether they might be detailed parts with big overhangs or big mechanical parts that are fairly linear and geometrical. And you'll get a feel for what kinds of parts need that extra cooling and what kind of parts can handle it without cooling. And then there's some materials like ABS where you want absolutely no cooling whatsoever. You need your cooling fan turned off, and in fact you don't even want the fan that blows on your hot end to blow on your print, because it can result in warping and layer splitting. Besides the first three categories, which is fan speed and then subcategorized into regular and maximum, there's this regular maximum threshold, which basically gives you a layer time at which the fan speed will then begin to increase towards maximum. So if it's a so for example, if it's a layer that is going to take a fairly long time to print, it's just going to use the regular fan speed. Now, if it's a small layer that might print really fast, where the plastic would stay molten otherwise, then it will begin to increase that regular fan speed up to the maximum fan speed once it goes below the fan speed threshold. Here you can tell it what height to use regular fan speed. So again, if you're using a printer that has a layer fan, you can tell it to not start the fan until it reaches a certain height on the part, or you can also specify it with respect to what layer it's on. Now, if you're using a printer that doesn't have a controllable fan, and you simply have to wire that fan in to constant voltage, or you're using a printer that doesn't even have a cooling fan yet, minimum layer time can be one of the most important tools for getting clean prints. So if you set that minimum layer time to somewhere in the 20 to 30 second range, that is a pretty solid bet for printing with PLA or PETG. And what will happen is that if it gets to a layer that's going to take less than that, it will actually slow the printer down so that it takes at least that amount of time. And that amount of time will give the plastic enough time to start to harden or cool, so that by the time you move on to the next layer, you're not printing melted plastic onto still melted plastic and getting a messy, disfigured part. So this is very important. Even if you have cooling, if you don't have a super strong cooling fan, there's only going to be a maximum speed that you can kick each layer out at without deformation beginning to happen because the plastic hasn't fully cooled. So cooling is really important to producing crisp, quality prints. This final value here is minimum speed, and this basically just says don't ever go lower than this speed. And this is important because in some cases you're not actually extruding fast enough to get a clean bead out of your nozzle. It's basically going to extrude out kind of irregularly, and you'll get a really poor quality layer line as a result of that. This final one would give you the option to lift the head if the minimum speed is hit, and the minimum layer time hasn't been satisfied yet. The only problem with this is that it pretty much guarantees you're going to ooze plastic out even with a good retraction if it's just sitting there waiting. So I tend to not recommend that you use the lift head option. It's pretty much always better to just get better cooling, or if you're printing a tiny part, print multiples of those tiny parts. Print one tiny part on each corner of your bed and just reduce the likelihood of the part having a still melted layer in that way. Just basically add print time to each layer by giving the printer something else to do. And that is almost always going to be a better option than just letting the nozzle sit there at temperature waiting and oozing plastic out. Okay, support. This is a big category. A lot of these are options that are really part specific, and there's not going to be a good way to tell you what settings to use until you are actually working with a specific part. But there are some things we can go over in a more generic sense that will perhaps inform decisions that you make when enabling support for more complex models. So placement's the first option, and is pretty simple. Everywhere means that anywhere there's an overhang that exceeds the minimum overhang angle, it's going to generate support, even if that support is resting on another part of the model. Whereas touching build plate means that it will only generate support if the area that it is generating it in will go down and touch the build plate. It won't touch another part of the model. Typically, if you need support significantly enough, you're going to be better off generating it everywhere than trying to prevent support material from being generated on the part and then having an overhang that fails because it needs support. This is one area that I think Cura has a long ways to go. Automated support placement is a crutch at best. Being able to add that support manually and tell the print software exactly where you want it and where you don't is where they need to be headed. And I'm hoping that that'll be in a future update because it's a pretty critical feature to have, I believe. It's something you'll hear people who use Simplify 3D talk about heavily, is the ability to do custom support, and it's a great feature to have. So if you're watching this, Cura developers, custom support placement would be outstanding. Overhang angle, this is the angle at which it will begin to generate support. So for most printers with decent performance, something like 60 to 70 degrees is a pretty good value. That's where the ability of the nozzle and your cooling system to keep the part from drooping or curling starts to attenuate, and you need some type of support to help keep each layer from basically falling because of gravity. So everybody's printer will handle a little bit different nozzles, different hot ends, different cooling again. All of those are going to affect your maximum overhang angle. And if you go on Thingiverse, there are some kind of overhang angle torture tests that will let you, in one part, print a whole bunch of labeled overhang angles, and you can figure out what your printer's maximum clean, unsupported overhang angle is, and what point you need to start adding in support material to get clean prints. Support pattern. We've seen probably most of these before because they use the same patterns, and typically what you're going to find is that if you need your support material to be really strong, grid will create a strong support. material structure, but it's going to be more work to get out, and it's going to use more material, which means it's going to add more to your print time. Lines will not add a lot of print time compared to grid. However, they are single lines of extruded plastic, and it's relatively easy for them to get knocked over if they have to travel a long vertical distance. So if you've got short heights that you need to support, line comes off fairly cleanly, doesn't take a lot of time or material to print. But if it turns into really long, tall support areas, it can be problematic for some printers. Zigzag is kind of like line, but every other endpoint it connects the support material. So it's kind of a cross between grid and lines. It's faster, it uses less material, but it's also a little more stable and less likely to get knocked over. And I actually think that zigzag is probably one of the best options in Cura right now. Triangles is exactly what it sounds like, and concentric basically means that it will form sort of rings of support material within the volume that needs to be supported, and it will resemble a shape, outline shape, similar to the area that it's supporting. It's useful in some cases, but it's not something that you'd probably use every day. Connect zigzags. This is the option available for zigzags that helps increase the strength and makes it a nice compromise between lines and grid. Support density. This can be selected either by percentage or by a specific distance you want it to support. And for most printers and most parts, a support angle between 10 and 20% will be sufficient. If you go too much higher than that, it's going to be a pain to remove. Too much lower than that, you're not going to get sufficient support. The XY distance is how far it stays away from the part, so it's going to stop 0.7 millimeters in the XY when it's generating support material. And then the Z distance is how much of a gap it leaves between the support and the part. So the bigger the gap, the easier it is to remove, but the rougher the surface, the support surface will be. And then the smaller this value, the harder it will be to remove, but the cleaner your supported surface will be. Okay, so StairStep height, this basically has to do with how often it increments the height of your support material when it's supporting a slope. And you can do a really fine stair step, but kind of like the Z height, it's going to make it harder to remove. And then if you make that too large, you're going to end up with ugly bridging on that support, that angled support. Alright, so the join distance basically just says if two supported features are within this distance, just make it one support structure, don't make two separate ones. Horizontal expansion. This will actually enlarge your support area by this amount to better support overhangs and bridging. So area smoothing is a little bit of a strange one, but what it attempts to do is sort of smooth out sharp or small features into a more continuous support area. It will be easier on your printer, and it will, in some cases, actually create a cleaner support interface. All right. So towers. Alright, so towers is another feature that's new to Cura 2, and this basically creates a more robust support structure for really small areas by making the support actually larger until it gets close to the area that it's supporting, and then it tapers back down and forms kind of a roof. So if you've ever been frustrated in older versions of Cura with tiny support areas having support material that wasn't even able to print successfully, it just kind of got wiped away and stuck on some other part of the model, the towers feature might make that work better. And then these last three items are simply dimensional parameters specifically for those towers if you enable them. So it'll tell you how big a round it should be, what the minimum diameter of a feature that you want to use towers for should be, and then the angle of that roof that the tower generates. Alright, that's support material. Moving on to platform adhesion. This is a good category to understand well. First off, we've got skirt, and this is just going to print a line or a number of lines around your part, and the basic value in this is that it primes the nozzle for you, and it lets you quickly verify how good your bed level is before it starts the part. So you can tell it to do only a single line, and this will tell you how far away from the part you want it to be generated. And then also, as a final modifier, you can say, I want to make sure that it prints at least this much material, and if it doesn't, keep adding lines until it's printed that much material, just to verify that that nozzle is fully primed. Okay. Next up, we've got brim. And brim is kind of like a skirt, except it is attached to the part and is typically printed much thicker than a skirt. The goal behind the brim is to either stabilize the part, if it's a part with strange dimensions where the area touching the build plate is relatively small and you just want more surface area for bed adhesion. And then another one that's used for heavily is to prevent warping, especially with materials like ABS. And it is typically a pretty effective tool. And brim is usually pretty easy to remove as well. And a lot of times a brim is much easier to remove than a raft, and the raft is the last item in here. The raft is actually a substrate of material that gets printed that the part is then printed on top of. I don't like rafts, and I typically recommend that people not rely on rafts to get good prints. Sometimes people find that their prints work better with rafts because their bed's not level, and the raft gets extruded in such a coarse manner where the gap between the nozzle and the bed is so large and it extrudes out so much material at once that it can kind of absorb those bed anomalies. But it uses a lot of material, it spends a lot of print time, and then you've basically got the entire bottom of your print being printed on top of this raft with a gap large enough to remove it, and now your bottom layer has kind of a rough, unfinished look to it. Even the best printers out there can't produce a first layer on a raft as good as a first layer on the actual build plate. So I'm not actually going to go through all of these settings, again, just because I really don't recommend that you rely too heavily on rafts. There are some scenarios where a raft is a better option than either a brim or a skirt, but those are very few and far between. In almost every scenario where you think a raft might be necessary, you're probably going to be better off with a brim, and or resolving the mechanical issue with your printer if it's unlevel bed, or your bed adhesion issue if you're just not getting prints to stick well. So Cura's got a few mesh fix options. If you've got an STL that you downloaded or that you made that's got some weird behaviors going on, maybe there's some holes in it where the meshes aren't matching up, and it'll attempt to fix those for you. So it'll add overlapping holes. You can have it remove all holes, like for example on the interior if you just want it to be a solid part with just the exterior. You can have it try to go through and stitch up holes in the mesh. This is pretty common in parts that have been generated in programs like SketchUp, for example, where it's pretty easy to create a model in SketchUp that doesn't have polygons that are fully connected to one another. And then, or you can just tell it to keep disconnected faces. These are all sort of designed to help fix bad models, to be honest. So hopefully you're able to get models that are already what's called watertight, where there's no holes in the mesh and there's no issues. But if you've got one and you don't have access to the design files or the designer to ask for a revision, using these can sometimes help turn something that's unprintable into something that's at least printable. Special modes, not a lot going on here. There is print sequence. which if you're printing multiple parts, you can have them print all at once, which is standard, or you can tell it to print one at a time. I would caution you, if you attempt to have it print one at a time, you must have the dimensions of your print head accurately outlined in your JSON file that defines your printer parameters, because if you do not, and they're all zeros, or they're just wrong, the printer will actually run into other parts as it's trying to print and make a big mess. So I recommend this only be used by advanced users. Those are kind of interesting. Most of the time you're just going to be using normal. However, there is an option that lets you just print the surface of the part in a single wall. So these are typically not super functional parts if you were to do this, but there are some applications where it can be useful, or if you're just looking for an interesting effect. And then both sort of combines normal and surface, where internal volumes are printed normally and external surfaces are printed as a single line. And then finally, the spiralized outer contour is often what people refer to as the vase mode, and this is a great way to print a single wall vase, where it'll basically print a bottom and then it'll print the walls in a continuous spiral. So you basically have no layer change lines or minimal layer change lines due to the constant rate that it's printing at and the very linear path that it takes. All right. So experimental has some interesting options in it now. Enable draft shield. This will let you create actually a wall around your part to try to keep drafts off of it. So if you're printing with ABS, you don't have a printer with an enclosure, and you're struggling with delaminating, cracking, lifting, warping, things of that nature, trying to print this draft shield could produce a cleaner ABS part. Now, naturally, it's going to take a lot more time and use a lot more plastic, but if you're wasting prints on failed, or if you're wasting plastic on failed prints, then the draft shield might do the trick. And then finally here, we've got coasting. Coasting is a really cool feature, I think, to play around with. And basically what this does is that it stops extruding before it actually reaches the end of an extrude path, and it allows the nozzle pressure that's built up to basically relieve by extruding the final portion of the line. And then when it goes to do that move and it retracts, it's basically already deprimed the nozzle and removed any pressure in the nozzle. And it, in a lot of cases, especially with high-speed printing, can really cut down on stringing and artifacts because of the ability of this to just get rid of that nozzle pressure in a constructive, efficient manner. Now, depending on your extruder and your nozzle size, these recommended values may have to be tweaked a little bit, and you're going to have to play around with them to figure out what works the best. If you begin to see under extrusion at the end of lines, that means that your coasting volume is probably too large, and you need to turn it down a little bit. Or it might also mean that it's trying to coast before it's actually moved long enough to build up nozzle pressure, and you actually need to increase your minimum volume before coasting a little bit. But I'd recommend most people play around with these a little bit, because I think it's a pretty smart solution to stringing and blobbing. And then this extra skin wall count. This is a feature that's used to improve the roof of your part when it starts on infill material, and basically it replaces some of the outside top-bottom lines or patterns with several concentric lines, and it can create cleaner roofs in this scenario. It's probably not something that is a huge issue you run into a lot, but if the part of your print that you're unhappy with matches this description in terms of where that roof is starting, enabling this might clean those up a little bit. Alright, then we've got the alternate skin rotation, and this allows the top and bottom layers to be alternated instead of only going in one direction. Could create a stronger part, could result in a cleaner surface if you're having issues. Probably not a huge one, but certainly something to look into if you're running into problems there. And then conical support, if we enable that, what this will do is taper your support to save on print time and print material. And the only downside to it is that because the supports start off smaller at the bottom and then get larger at the top, there are some scenarios where the geometry might result in that support material getting knocked over if it doesn't have enough surface area on the bottom to actually stick to the plate. But for some scenarios, it's probably a great idea. And it gives you some nice options here in terms of the angle to run at and the smallest diameter you will let it taper down to basically ensure that you do get good bedside adhesion. So I think this is a great one. I think it's for sure going to speed up print times, use less material, and assuming you dial these settings in and are working with good bed adhesion, I think it's pretty much a win-win. Okay, we got through everything. That's it. Thanks for watching. Hopefully this helps some people. Now again, for people watching this in the future, Cura 2.3 will probably be out of beta by then, and there'll be some more features. I may do a follow-up video on Cura 2.3 to talk about some of the new features. Although if you made it through this Cura 2.1 series and you understand everything we talked about, the things that they add in 2.3 are probably going to complement what you already know about Cura 2.1, and it's not going to be a huge transition or a huge head scratcher as to what some of these new features are. That said, if anybody's interested in seeing that 2.3 tutorial once it goes out of beta and into current version, I'd be happy to do a follow-up and go over some of the new changes. They've actually added quite a few cool things, so I'm actually currently using the 2.3 beta for a lot of my everyday slicing, and there's some stuff in there that is pretty great. So once you're comfortable with Cura 2.1, you've gone through all these settings and you're using them and you know what they're doing and what they're changing, firing up Cura 2.3 is probably a good idea, and you'll probably find some more cool stuff in there that will improve your print quality and print speed. Alright guys, thanks for watching. I do appreciate it. This is probably the last slicer tutorial I'm going to do for a while. I've got a lot of other video topics and tutorials that I want to do, and these guys take quite a bit of time in terms of me sitting down and going through these and the editing to make sure everything's clear. So I don't want to just do software tutorials. I've got a lot of other stuff in the pipeline that I want to get going here. So comments and suggestions are always welcome. Thumbs up if this was helpful, thumbs down if it wasn't, and we'll see you next time.